The power levels in drag and roll race events here in Australia are continuing to skyrocket, and you don't really have to look around the pits too far to see the name Nitto. Nitto is synonymous with some of the most powerful engines here in Australia, and for that matter all around the world. And we're here with Christian from Nitto to talk a little bit about the design process and how they go about developing and manufacturing these parts. So Christian, for a start, there's a lot of engines out there that people want to make power out of. How have you at Nitto decided which engine platforms you want to support?
So basically the way we decide which engine platforms we'd like to support, a lot of it comes from the demand. So our bread and butter is obviously the RB, RB30 and RB26. And with Jim and Theo's experience in the past, the RB30 and RB26 were of high demand. So initially we started developing components for those engines. Then from there, we flowed onto the 4G63, SR20, all of which we have significant experience with. And honestly, from there on, you look at what we get a lot of calls for, a lot of inquiries for. And if we didn't have anything to service that market, we'd look at developing that market. So for example, 1JZ is a relatively new addition to our range. We've been receiving a few calls for those. So they're newly released. We released those, I think, early this year. And also the G16 out of the GR Yaris and the GR Corolla. So they are only relatively new, but we were getting a lot of calls for those. So we decided, let's go make a piston and connecting rod combination for those.
Okay, so piston and connecting rod combination at the moment, no crankshaft. I can only assume that there's a lot more work in developing and manufacturing crankshafts.
Yeah, absolutely. And we actually have explored the possibility of doing a stroker crankshaft for those. There isn't a lot of room to play with as far as I'm aware in the crankcase, but we will still continue to explore that because a billet crankshaft would be pretty cool for that. Having said that though, the limitations of the current crankshaft or the OEM crankshaft that comes in the G16 hasn't really been reached. So we don't quite know what the limitations are. So
not necessarily worth fixing a problem that doesn't exist just yet.
Exactly right. Exactly right.
Let's come back to the RB platform, because here in Australia, this is kind of the platform beside the 2JZ, and 2.5, 3,000 horsepower is now not uncommon with these. What has been the weakness with the factory crankshafts, and then what development process have you gone through as you've seen those power levels climb over the years?
So obviously something that we've been making a very big deal of in the past 3 years or so is the bearing, the rod journal bearing diameter and the actual width of the rod journal bearing. What we've done to tackle that is we've widened the rod bearing journal by about 20%. So it's about a 21 mil, just over 21 mil bearing. What that enables us to do is dissipate the load that the connecting rod puts over the bearing over a larger surface. So it effectively elongates the life of the rod bearing.
So essentially, this is something that happens as the cylinder pressures increase with very high horsepower. There's just more load being transferred down through the piston, the connecting rod, and into the crankshaft. So the wider bearing helps support that additional load, extending bearing life and crankshaft life?
Yeah, exactly right. More so bearing life than crankshaft. Crankshaft life, we've never had a problem. We've never had a single breakage with the RBs, actually. I never had really any problems with any of them. And another thing that it enables tuners to do is tune a bit more freely. So instead of having to tune to the bearing, so to speak, they have the confidence to know that there is that extra width there to support a bit more mid-range and a bit more aggression in the tune.
Safe to assume here you're not having your own custom bearings made. This is designed around an existing bearing shell that was already out there in the market?
No, completely custom bearing from ACL. We work with ACL race bearings. It is a completely custom bearing.
I mean, on that note, I know this is a common way of going, using an existing bearing. Could you just not find anything that sort of fit the bill as to what you needed in terms of width and diameter?
I think that's more or less what it was. Jim had a certain idea in his head about what he wanted, and that didn't exist. So contacted ACL, who are the best in the business with the bearings, and they were more than happy to work with us on something. So that's the path that we've taken.
Okay, that's really interesting to find that out. You also mentioned with that diameter, by increasing the diameter of the crank pin, basically you end up with more overlap with the main journal of the crankshaft, which then aids the reliability, strength, rigidity of the crankshaft as well. In terms of material, is there anything fancy going on with the crankshaft material, or is it all they're all made of the same materials now?
The vast majority of our crankshafts are made out of a 4340 billet material. However, for the high horsepower applications, we do offer the EN40B, which is an upgrade from the 4340. So a lot of the big drag cars you'll see, particularly in Australia and overseas now as well, they do feature that EN40B crankshaft. Not that we've ever had really a problem with the 4340s, but we did want to offer that alternative in case people did just want that extra peace of mind. So the EN40B has actually become quite a popular alternative.
Now, there's obviously other reasons to go with an aftermarket crankshaft or rotating assembly in terms of getting a certain stroke or a certain capacity. But in terms of power levels, could you give us an idea of at what point you would recommend moving to that wider conrod bearing, and then also at what power level that EN40B material sort of comes into play?
Well, to answer the first part of the question, I'd say probably around that 1100 horsepower mark would be a good idea to move up to that wider bearing. More for reliability's sake. We have seen significant power figures being run on the standard bearing, but at your own risk if you want to really push to 2000 horsepower on that. So in terms of the 4340 to the EN40B material, they really feature when you want to go that 1700 horsepower level and above. Commonly that's where you see it. Not that the 4340s can't take any more. They can, and it has been done multiple times before we release the EN40B, but generally that 15 to 1700 horsepower bracket, people generally go for the EN40B.
Okay. Now, talking about the process of design, development, and then validation of these components, I can see in your cabinets behind us, you've got a lot of 3D printed componentry. So talk us through the development process in-house and the use of 3D printing.
Look, 3D printing is a massive part of the development that we do. We've got our own 3D printers in-house, so we draw everything in-house and then we'll 3D print certain things. We've got a big crankshaft over there that we didn't get printed in-house just because the machinery is quite expensive to do that. But all of the prints that we have on display today are made out of resin. They're printed in a resin printer, and what that enables us to do is get an accurate depiction of the crankshaft or connecting rod. And what we go from there and do is we fit the crankshaft into the block, fit the connecting rod to the crankshaft, fit the piston, and we rotate the actual assembly inside the block to make sure that clearances and everything are sweet.
So much, much cheaper to find that you've got an interference issue with a 3D printed component before you actually go through a very expensive manufacturing process.
Yeah, absolutely right. And also with our CAD software, we can do a similar thing, but we do like to see in the flesh what it actually looks like. It does help having a visual representation like that because this computer screen doesn't always give you the best representation.
Sure. Okay, the other thing that caught my attention on your stand is a 360-degree roller bearing thrust washer bearing assembly, if you like. Interested to find out a little bit more about what that's used for, why that's been developed.
So basically what we found is with the current range of RB30 crankshafts, RB30 wide journal crankshafts, the Torrington bearing on the much higher horsepower application cars is starting to be chewed out a little bit on the side. So what we've decided to do is incorporate a 360 degree support for the Torrington bearing, and that enhances the reliability of the overall setup. As you said prior to the camera, it's a lot of the clutch engagement, disengagement that causes a lot of the force, and they've noticed that that's highly the case in higher horsepower applications. So we've decided to service that area of the market. We have 3D printed it, as you said, tested it in a block, and it all seems to work quite well. So from here on in, our whole range of RB32 wide journal crankshafts will feature that 360 Torrington support. So that's the plan.
So on that note, is it a requirement to run that roller bearing 360 thrust support, or can you still run the conventional thrust washers? Is it optional to go between the two?
Optional to a certain power level.
And as you mentioned, just to clarify, that thrust movement, essentially hard to say without having something in front of us we can move, but that's when you put your foot on the clutch, you're physically trying to essentially push the whole clutch assembly and hence crankshaft forward in the block. So that needs to be supported, and if that's not supported properly, we end up with significant wear on the crankshaft, destroying the crankshaft ultimately, and then even destroying the engine block. I also spied on your stand a new oil pump for the Nissan SR20, and I'm interested to dive into that. So what is this product and why is this necessary?
So it's a full billet SR20 oil pump, multi-fit to suit all the variations of the SR20. Basically, we've seen a gap in the market for a quality oil pump for the SR20. Granted, they don't have too many issues compared to the RBs. We still do see the potential for a product in that space. What we've decided to go with initially is the standard flat drive inner gear. We are also developing a Sine drive for that, but we will release more details on that as they come to fruition.
There's a few elements there I just want to dive back into. So the flat drive, essentially, as its name implies, you've got two flats that mate with matching flats on the crankshaft, and that's how it rotates. Same with the RB, although there's some engagement issues there with the earlier crankshafts. And then with the RBs, when you go to your billet crankshaft, you also have the option of this Sine drive, which is a different style of engagement. We've got some shots of that we'll show here. So what are the advantages of that Sine drive over the flat drive?
Well, basically the advantages of the Sine drive over the flat drive is that you have more surfaces to actually contact the crankshaft to the inner gear. So as we've seen with the double D design, sometimes called, or the flat design in the standard pumps, is that those surfaces wear out quite easily, particularly in standard pumps. With our billet gears, we don't see it too badly, but for higher horsepower and higher oil pressure applications, the Sine drive is certainly a suitable option. You get that greater reliability. Also on the crankshaft collar for the RB Sine drive, we do use the full length of the gear, whereas on the RBs, it's a bit more difficult to do.
You mentioned already before, but in terms of the oil pump material, the RB26, most people in the RB world know if you spin them much above about 8,000 RPM with a stock oil pump, they'll shatter. It's a sintered metal, as I understand it. It's not, the strength isn't there. Less of an issue with the SR20, but I'm guessing here you're moved to a billet material for those oil pump gears, so no chance of failure?
No, absolutely. Definitely moved to the same material as the RB26/30 oil pump, which is an EN26. And we also super finish those in-house to give it just that extra hardness.
Okay, does it move more volume of oil? Is this a consideration than the stock pump as well?
Yeah, absolutely. It's definitely a higher volume oil pump, higher oil pressure oil pump. So we have had those oil pumps, our SR20 prototype oil pumps, logged to about 140 PSI. And using a DET application, we have had them logged to about 130, dare I say a little bit more. So we do have that extra oil pressure ability for the VE head, sorry.
Okay, so the VE head, for those not in the Nissan world, is essentially a VTEC mechanism, so it uses more oil volume in order to actuate that VTEC mechanism. So I understand the requirement for more oil volume. Without the requirement for that volume, moving that same volume of oil and not using it obviously results in more pressure. In terms of an engine where you don't need that oil volume, maybe it's a D or a DET, so you don't have that oil volume requirement, do you have a way of regulating that down? Is it a fixed spring or an adjustable regulator?
So at the base of the backing plate on the back of the oil pump, there is a mechanism to adjust the oil pressure up and down. So you do have to take the sump off, unfortunately, but you do have that ability to adjust.
I mean, of course, it's not something that you're going to be adjusting every race weekend. Once you kind of found that sweet spot, it's going to be there to stay. Look, Christian, great to get some insight into these products. Thank you very much for your time, and we wish you all the best.
Thank you very much for your time.
If you like that video, make sure you give it a thumbs up. And if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.